Yeah, I just wanted to show you this before I put the unit together. Last time I talked about doing the wiring, and I did the wiring and it didn't work. There were a number of problems, and most of it was these connections. These are those ones they use on the breadboard. Let me put you up here. Okay, what had happened was the connectors on the end of the motor, which are these guys. What I did was I plugged these wires in. They wouldn't fit into the socket on the this board. This board here. Now, these plugs that were on the end of the motor didn't fit this white thing. So what I did was I stuck these into the plug, and then I had to use these other pieces, and I had to snap them together, and then these plugged. I put this in the plug and then this on the board. This end here was on the board. This end I put into the plug. And what was happening was that this connection here wasn't really making a connection. I mean, here it's tight, but if you rotate it a little bit, it just comes apart. But you know, they're cheap connectors, and I was just trying to put it together, see if it worked. And the connection here failed, but I didn't know it at the time. So this was from a Curious Scientist, and I don't have the YouTube channel that he had this under. It was like two of these. He showed two of these on a breadboard. There was a breadboard and a microcontroller, and this board for the motors were off to the side. And then I don't remember the exact name of it right now, but I'll get it back. But anyway, I tried hooking it up, and it didn't work. And like I said, part of the problem were these connectors. Of course, I didn't know it at the time. And the other problem was that I was going off of this card that came with the motor, and it has an A and an A slash, a B and a B slash. So those are the coils. There's one set of coils and two set of coils. And on this, I guess you call it a driver board, it has a 2B, a 2A, a 1A, and a 1B. So I was thinking, well, the 1A and the 1B was one set of coils. The 2B and the 2A was another set of coils. So that's how I hooked it up. but it didn't work, and it was jittering. This is the motor that controls going to control the rotation. This is the motor that's going to control the piece on the top that's going to rotate. Now this piece on the top, I'm going to use a Arduino and use the step indexer program so I can rotate it. And this piece on the side, I was just going to use a hand wheel to rotate it manually wherever I want, and then lock the unit in place. Of course, I'm going to put some kind of digital readout on it so I know, in what position it is. But I didn't want to use a program for this one, because if you go the wrong way, you're going to rotate it and you'll crash. So I'd rather manually use this and then use the Arduino for this one. But the motor connections, you see I got the green wire, which is the A minus. I got that on the 1B. And the black wire, which is the A plus, I got that on the 1A. So the coils go to the 1 and the 1 and the 2 and the 2. They don't go between the A and the B. You got to go by the letter. You don't go by the number. So it took a while to figure that one out. So the blue one goes to the 2B, and the red one goes to the 2A. For this motor. Now other motors, it might be different. But anyway, I ended up, when I first hooked it up, everything was jittering. So you could tell it was engaging, but it was only, you could still move it. Like only one coil was engaging when I hooked it up the way I thought it was. And then I had to basically, try this and try that, and pretty much process of elimination. So I figured, well, obviously these people who made the board, they think a little different than we do. So, like I said, I ended up using the letter instead of the number. Green and black. Green and black. Yeah, you use the no, you use the number and not the letter. So the green and the black go on the number 1, 1B and 1A, and the red and the blue go on the 2A and the 2B. But anyway, I did the best I could. I spent about 3 hours playing with it, and I couldn't get it to work. So I took it to the e-shop at work. Had those guys look at it, gave them a half a dozen donuts, and So it was like 2 days later, they called and said, "Yeah, well, we got it going for you." And so I slipped them a 20 for their time and effort. So what the whole situation was they took this plug off the end of the wire. You could take these plugs out. I guess you push something here and these wires come out. So they put a little heat shrink on here. Now they'll fit into the board. And they're a nice tight connection. So that eliminated these two connections here, which was causing most of my grief. So if you take the wire out of the plug and you put a little heat shrink tubing on there, you save yourself $20 from having to take it somewhere and have somebody look at it. Of course, it probably cost you a lot more than that, because the guy over there, he's not just a computer guy. He's like an electrical engineer. He designs circuits and boards and all this other stuff. I have no idea what he does, but I was happy, and he was happy. So anyway, I got it to work, and for the 12 volts for the board, I got the power supply. I think I showed you that earlier. And then for the 5 volts for the encoder, I'm using a jack off of a phone. I got the wires split over here. So I just wanted to show you that before I put it together. So I'll go ahead and plug it in. I'm going to plug in the power supply. Now you can't see it, but it's got the little green light just came on. So I got this phone jack I'm going to plug in here. Now I got lights on the light came on here. Little red light. The light's on the power supply. So what I got is I got the positive and negative 12 volts coming in over here. Then this is for the motor, and I'll have to explain this later. But there's an important thing you got to do here is, believe it or not, this little guy right here, that's a pod. It adjusts voltage for the motor. It doesn't look like it, but it is. And you would think that it looks like it takes a Phillips, but it's really a flat bladed little screwdriver. So you have to adjust the voltage for your motor. Now when you would think you turn this left and it decreases the voltage, but it doesn't. You have to turn it to the right to decrease the voltage. And you turn it to the left to increase the voltage, which is counterclockwise. But here's the wiring here. This orange wire is on the end of that. There's three sets of pins on here. Well, there's 3 pins and there's 3 rows. So there's 3 pins here, 3 pins in the middle, and 3 pins on the bottom. Now these 3 pins on the top, from the far side, one is direction and one is the step. Now it doesn't really matter which one goes where, because the motor is going to turn one way or turn the other way. If you rotate the wires, then it'll be opposite. So it really doesn't matter where they go. It all depends on the rotation of the knob. So this last one, I forgot what they call it, but it goes to the ground. Now the ground is the bottom set of pins. The 3 pins on the bottom are the ground. The 3 set of pins in the center is the power. So from the far side, which is where the orange wire is, that's step and direction. And then this other one goes to ground, and that grounds the motor, or grounds the board. And then the pin in the middle, I'm only using 1, but there are 3, and that's the power for the board. That's coming off of the phone charger. So anyway, I turned it on, and this motor's not hooked up. This is the only one that's hooked up, and it's locked up. I can't rotate it. This one I can rotate because it's not hooked up. So then when I turn this wheel, it rotates. Can you see it? So that's working. Now the idea behind this was that you can rotate this motor without having to use a microcontroller and a program. You can do it manually, which is exactly what I want. So that worked out real good. Now on the back of this, this is your step, this is your direction. It doesn't matter which one you use. You could switch the wires. Like I said, it's just a rotation of the motor. And then that one is that's the ground. And then the one on the outside is the power, the 5 volts. So you got to power this with 5 volts, and you have to power this with 5 volts. You can use the same 5 volts. That was one of the other things I was doing too wrong, is that I was powering this with 5 volts, thinking it goes into here and powers that, but the light never came on. So anyway, that's pretty good. Real happy about that. All right. Talk to you later.